know it's a little hard to read here. So let's talk about our properties of integrals. So from 0 to 6, the function f of x d of x is 10. From 0 to 4, it's 7. From 4 to 6, obviously it's what, guys? 3. Because 7 plus 3 would be 10. Are you comfortable with that one? How we set up? So I said from 0 to 6, it's 10. So from 0 to 4, it's 7. Oops, excuse me. So that's 7 plus what? And from 4 to 6, 7 plus what gives me 10. We good? All right. If you get one like that, be ready to rock and roll with it. All right, good stuff now. Use 3 rectangles and the left-hand endpoints to determine the value of from 0 to pi over 2 sine of x d of x. So I know we could, it's saying use the Riemann sum left-hand endpoints, okay? So this is A, this is B. How many rectangles am I going to make? 3. So the width each time would be the B minus A, bless you. So it would be B minus A over the number of rectangles. So pi over 2 minus 0 over 3. So the width of each of our intervals is going to be pi over 6. So what I recommend doing is think about how we're going to go from 0 and then let's find those values. What is the sine of 0? 0. Pi over 6 would be our next interval. Okay? And at the same time, let's think of its output. And I'm thinking this is x, and this is my f of x, if you will. What is a sine of pi over 6? 1/2, good. What's the next one? It'll be pi over 6 plus pi over 6, so pi over 3. And what's the sine of pi over 3? Square root of 3 over 2. What's the next one? Pi over 2, right? Because it'd be 3 pi over 6, which is pi over 2. And so what's the sine of pi over 2? 1. All right. Now I wrote all those. And if we're going to do 3 rectangles, and it's length times width each time, or width times height, that's how we're thinking about it. Our width every time is what for our rectangle? Pi over 6. So our width is pi over 6 times, and I said use left hand endpoints, so we're going to use this one, and this one. So we're going to say 0 plus 1/2 plus square root of 3 over 2. So we're going to say pi over 6, let's see, 1/2 plus square root of 3, so it'd be what? 1 plus square root of 3 over 2, and then I could take that times pi, and we could say, I'm trying to think the best way how I want you to write it. That's okay that way. Let's grab our calculators and let's get an estimated answer. Make sure your calculator's in radians. And remember, this is an approximation. This is approximation. What would be different if I said use right hand endpoints? You would say pi over 6 times what? 1/2 plus square root of 3 over 2 plus 1. Okay? What if it was trapezoidal? Using the 3 trapezoids. you'd say b minus a over n times 1/2 in front. And remember what you would do with these? You'd say one of these, two of those, one of those. But you'd also have the 1/2 b minus a over n, because that width of the rectangle is actually the height of that trapezoid. I think I have one of those coming up. Okay? The speed of a runner increased steadily during the first 3 seconds of a race. Her speed at half-second intervals is given. Find a lower estimate for the distance that she traveled during these 3 seconds. So, everybody see how this function is increasing over time? Everybody agree with that? So, it may not be linear, but it is doing this. Something like that. As we go, time increases, this is increasing. So if I want a lower estimate, and then should I be doing left or right hand endpoints? Left. Because look, if I was doing this, see how I'm missing these parts right here? Versus, now let me erase that, versus if I was doing right, see how that would be an overestimation every time? All right, good deal. So we said a lower estimate, so we're going to do left-hand endpoints. What's the width every time? What is it? 1/2, isn't it? Aren't we going 1/2 each time? So it's going to be 1/2 times the sum of this, but not that one, right? So that would be the right-hand point. So I'll say 0 plus 3.7 plus 8.3. Then you guys get your calculators and crunch that for me. Plus 13.2. Plus 15.1, plus 15.7, plus 16.2. Oh, I don't need that last one, do I? Thank you. Thank you, Ms. King. Anybody have the value crunched for me? 24 right on the money? 28? 3.7, 8.3. I'm going to let majority rule. 28? Yeah. We good? Okay. Would you be fine if we took tests right now over that material? No, really? Over left hand and right hand?
Is there going to be one of the tests that's use the rectangle ones that might the closest?
So we're going to scribble out that left and we're just going to call it right. Okay. Well, first of all, our interval goes from 0 to 6. And it says 6 subintervals. So b minus a, 6 minus 0 is 6, divided by 6. So our width of each rectangle is 1. Okay. So the width of our rectangle is 1 times. So if we're going to do right endpoints, I'm going to do the f of 1, which is right there. Let's go ahead and call that 3.5, okay? 3.5. Plus, so our next right, do you guys want me to draw the triangles? Does that help? I'm going to draw the triangle. So I'm going to go up. There's my first one. So, boom. Here's my next one. Boom. So what's that height at f of 2? 4. Plus, I'm going to go up. Look, I only go to there. What's f of 3? 2 plus, I'm going to go right, ooh, what is, oh, that's wrong. Where am I at? F of, let me erase that. F of 4, look at this, guys. F of 4 is right here. That's my rectangle. What's f of 4? Negative 1. F of 5, right there. Let's see, that would be what? Negative 1, negative 2. You guys want to call it negative 2.5? Agree on that? And then f of 6 is 3. Or, excuse me, not 3. Negative 3. Plus negative 3. Which, this makes sense because this curvature goes below, so that's a negative value. So we're going to get a positive minus some negatives. So we're going to add these up, multiply it by 1 so we don't even have to. So 3.5 plus 4 plus 2 plus negative 1 plus negative 2.5 plus negative 3. Anybody have that crunched for me? 3 right on the money? Okay. What's that, Cookie?
So for all these, you put.
Okay, so I give you a function from 1 to 6. Find the Riemann sum with n equals 5. So we're going to take the correct 3 decimal places, taking the sample points to be midpoints. Okay, so what you should do is you should set up a table. And stay on that problem. Okay, so what I'm going to do is I'm going to set up my little table from x to f of x. I'm starting at 1. I'm finishing up at 6. Guys, look how nice this is. What's 6 minus 1? 5 divided by the number n5. So we're going increments of 1. So I'm going 2, 3, 4, 5, and then there's 6. But I'm taking the midpoint. So you see how that table is not ideal for me. Because I'm going these increments. So I'm going to have 1, 2, 3, 4. What did I do wrong? So our width of each rectangle is 1 times, what's my first height? F of what? Cam? 1.5. Isn't the halfway point between 1 and 2 1.5? So put F of 1.5 plus F of 2.5. Plus F of 3.5 plus F of 4.5, and then one more, right? F of 5.5. Now it's obvious that we have to use a calculator on this, because what we're going to have to do is we need to find what the square root of 1.5 is, enter minus 2. So I want everybody to get those. And what here's what I would do. Here's how I would recommend doing it. I'm going to go to my calculator because I let you have it. So let me do it with you. So does everybody have that written down? Because I think I'm going to lose this when I exit out of here. Okay? I'm going to open up my calculator, it's going to take a second. I'm going to graph that thing, and I'm going to go to the table, and I'm going to get those values. I'm going to type in 1.5, 2.5, and then we're going to go from there. So let's graph that. Well, the square root is simply x and then minus 2, right? Yeah. So I'm just going to go here to y equals, we'll make that the square root of x. And then minus 2. I'm going to go to my second window table set and change that independent to ask. And then go to your table, second graph. And what do I want? I wanted 1.5. I wanted 2.5, 3.5, 4.5, 5.5. Is that correct? Add those values up, and that's my area. Can you guys crunch that for me? Add those values up. I'll leave it up on the screen. If you crunch them for me. So, what do we get? Just so I could write that in. Say it, Sarah. Negative.
0.857.
So approximately negative 0.857. Okay? While I'm here, look at the difference. That's an approximate, right? If I went back to my calculator and I graphed that, well, we better be getting a negative answer. That makes sense? And then if I got out of there and said, what is that? Let's find the exact. The alpha F2, number 4, what was it from 1 to 6? Is that correct? I know we did midpoint sum. Alpha F4 d of x. How close were we? We weren't too far off, were we? That was a pretty accurate, to be honest with you, that's a pretty accurate midpoint going in just 5 seconds, or in 5 intervals. So we've done some left, we've done some right, we just did a midpoint. You guys gonna make it? Let's do one more example, then I'll give you a break. Evaluate the integral by interpreting it in terms of area. I think I did this one for you already. But if we're thinking about in terms of area, I know, because you guys don't know how to take the antiderivative of the square root of 4 minus x squared. I haven't taught you U substitution yet. Okay? So if you're thinking in terms of area, that means think of it in terms of what the graph is. And I think I did this one for you before. If I graph that, that's a semicircle. From -2 to 2. And that equation has a radius of 2. Because r squared. So you would just say 1/2 pi. Your radius is 2. Squared, so half of 4 pi, which is 2 pi. That would be the only way you could do that one. Take a restroom break. Just this straightforward in the notation. I may rewrite it somehow and say in words, what's the derivative, or what's f prime of 3 at the antiderivative of this? Okay? You got to know what that means and understand it. It's not going to just come at you just exactly like that for every problem.
Mr. Bags,
Yeah.
when do you know whether to do this or the one that's like FB minus FA?
That's a great question. So here's the question. How do I know to do this versus f of b minus f of a? Well, first of all, f of b minus f of a is never going to ask you to do the derivative of the antiderivative. So it's just going to be the integral of. And it's also going to be from a constant to a constant. Now this is a constant to a function. You with me? All right. And what I can do on the test is I could just give you this and then say what's f prime of 1. So you're going to find the antiderivative. It's basically do the derivative of the antiderivative and then plug in 1. Okay, so if we do this one correctly, let's see here. You should be plugging in x squared for t, so 5. I guess I need to do that. 5 what? X squared minus 4, but then don't forget to multiply it by the derivative of x squared, which is 2x. I'm okay if you left it like this. Maybe the multiple choice question has it as 10x cubed minus 8x. So what if I asked this? So what if I had this? What if I said capital F is equal to this? And then the question asks for F prime of 1. So that means the derivative of this, which is that, and then plug in 1. So 10 minus 8 would be 2. Ah. Makes sense? Now you know it's going to be asked not in the exact way that I'm showing you every time. Is that the exact same? Okay, no, it's not the exact same problem. Now it's the derivative of the antiderivative from a function to a function of 5t minus 4 dt. I gave an example of this in your notes. Anybody remember what I said to do? Andrew, what did I say to do?
Like 2x to a constant, but then you put a negative in front of it because that would make it 2x to the top.
Perfect. There's something between 2x and x squared. There's something. Has to be. So I'm going to call it c. So I'm just basically, and let me go through the whole process again. I'm basically saying, well, the derivative, and then I'm going to go from 2x to that whatever c of 5t minus 4 dt plus from c, and c stands for a constant, x squared of 5t minus 4 dt. And we know exactly how to do this. It doesn't matter what the constant is. All we do is we plug in x squared here, and we multiply by the derivative of x squared. So this would become 5x squared minus 4 times 2x. Agree? But over here, it's always from a constant to a function. So how can I change that? I could negate it. So it's now negative from a constant to 2x of 5t minus 4 dt. So I could say 5 times 2x, which is 10x minus 4, times what's the derivative of 2x, 2, and don't forget the negative 2 out in front, So that would become what? Negative 20x plus 8 plus over here I had what? 10x cubed minus 8x. And I'm okay if you'd left it there. I would probably rewrite it as what? 10x cubed minus 28x plus 8. That is the derivative of the antiderivative of this. When does 9x minus 9 equal 0? When x equals 1. Before 1, 1/2. What's 9 times a half minus 9? Positive or negative? Negative. After 1, it's always... So I need to rewrite this because I can't take the integral of an absolute value. So this becomes from... When does 9x minus 9 equal 0 again? At what? 1. So I need to go from 0 to 1 of 9x minus 9 d of x without the absolute value. But hold on, from 0 to 1, my graph without an absolute value is negative. So I got to take the absolute, the negative of a negative becomes positive. Plus, from 1 to 3, 9x minus 9 of d of x. Now you can't, I remember one of the examples, these were symmetric, these are not. So you need to do these separately, right? What do we get over here for f of 3? 3 squared is 81 times 9/2 minus 27. Anybody think they have it as a fraction? 47 halves? 27 halves. Sarah, you're shaking yes. Anybody else get 27 halves? Yeah? Okay, so I'm going to trust you guys on that. 27 halves minus, remember, f of 1 was what? Negative 9/2, right? So you see how those become plus positive? And 27 halves plus 9 halves is 36 halves, which is 18. 18 plus 4.5 would be 22.5 or 45 halves. Yeah? Can you all just go in your calculators and type that in to make sure you can do a calculus? So b minus a, so 4 minus, or 6 minus 2, which is 4 over n. I want everybody to write that right here. That's your width. And then the height is f of, what was it for right? And I'm only going to do right. What was it? What was the rule? Anybody have it in their notes? A plus the width times I. So, thanks guys, you guys are awesome there. So f of, what's A? 2 plus 4I over n. Are we all comfortable where the 4 over n comes from? And this was the A plus width times I. We take this, plug it in right here. And that's your f of. So it becomes, if you do it correctly, becomes what? 2 plus 4I over n squared plus 1 times the 4 over n. What am I going to do next? Are we okay? Is everybody comfortable with this right here? What, I'm going to leave the limit as n approaches infinity out in front. I'm going to have the sigma touch each part, and I'm going to move the constant in front of the sigma. So 20 over n is a constant, so I'm going to put 20 over n sigma from I equals 1 to n of just 1, because that's all that's left, plus, what am I going to put out in front? 64 over n squared sigma from I equals 1 to n of what now? I plus 64 over n cubed sigma I equals 1 to n. What am I going to put in front or after? I squared. Now, I am going to now use our sigma property. So I'm going to take this. We're going to come up here. I'm going to give these to you. These formulas, the next thing that you're looking at in your notes, I'm giving those to you on the test. Nothing else, none of this up to this point I'm giving you. But I'm going to give you sigma of a constant. I'm going to tell you sigma of I squared, and sigma of I cubed. I will give you those 4 formulas right there with this problem. Okay? So then you're going to leave that limit as n approaches infinity. Right? And you're going to write, let's just leave that out in front. So you're going to say 20 over n times, what's sigma of a constant? Constant times n. No, times n. And 1 times n is n. Plus 64 over n squared times what's sigma of I? N times n plus 1 all over 2. Plus 64 over n cubed. And what's sigma of I squared? Anybody have it in their formulas? I gave you all of them. I don't even have n squared memorized. Or I squared. I squared. That's I squared, isn't it? Yeah. N times n plus 1 times 2n plus 1. Oh, I ran out of room. I got to write even smaller. It's 2n what? Plus 1?
Yeah.
All over 6, right? It's I squared, guys, because look, it's constant I squared. All right, let's go ahead and limit, touch each part, and let's start simplifying. So we'd say the limit as n approaches infinity of what? 20. Right? Because don't these n's cancel? Plus the limit as n approaches infinity. All right, let's do some simplifying. 64 over 2 is 32. Agree? and I could take out an n. So now it becomes 32n plus 32 all over just n plus, right, that limit as n approaches infinity. I know it's tight here on my paper. Now here's what I recommend doing. I first of all recommend taking out this n, so making this one go away and just leaving that n squared. Agree? What about 64 over 6? That's 32 thirds. But then, be careful. I also recommend right here this binomial that I can barely see. Multiply that. So n plus 1 times 2, is it 2n plus 1? Is 2n squared plus 3n plus 1. Is that right? So when I take that 32 times this, it gives me, no it doesn't, it gives me 64n squared. I'm going to write it right below it. I apologize for how tight this is. 64n squared plus, what would that be, 96n plus 32 all over, is it 3n squared? Look how nice this all works out. What's the limit of a constant? So 20 plus, the degrees are the same, so what's 32 over 1? Plus, the degrees are the same. If you don't get the degrees the same, you did something wrong, by the way. 64 thirds. So I get 52 plus 64 thirds. Let's see, 156 plus 64, right? 156 thirds plus 64 thirds gives me, does it give me 200 thirds right on the money? No, 220 thirds. So let's, thoughts? It's negative what? It's negative 9, isn't it? From negative 10 to negative 7, the full area from negative 10 to negative 7 is 1. From negative 10 to negative 9, it's 5. Then we skip from negative 9 to negative 8. And from negative 8 to negative 7 is 5. Well, that 5 plus what plus 5 gives me 1. Well, 5 plus 5 is 10, so 10 plus what gives me 1? Negative 9. Now look at that second one. You need to have the integral property touch each part. Because I know what y'all are going to say. It's negative 27 minus 5. Be careful. So this means 3 times from negative 9 to negative 8. F of x, d of x, minus, how would I write this? The integral from negative 9 to negative 8. That's not 5 times a function. That's just 5 d of x. Okay. So, what is it from negative 9 to 8? What we already established that it's what? So 3 times negative 9 would be negative 27 minus, no? Guys, what's the graph of y equals 5? Oh, okay. A straight line going through 5. Gotta be careful. From -9 to -8, that's what this means. What's the area? Well, 1 times 5 is 5, so -5, which is -32. Now, a lot of you would have told me. Now, here's where you got to be careful. Okay, a lot of you would have gotten this answer right because you just would have went -27 minus 5 because you got lucky. Because this width is 1 and this height is 5. But what if this width wasn't 1? Then you would have to take like 2 times the height. Or 3, whatever the width is, times the height. I can assure you I'm giving you one of these on the test. Make sure you understand this part. Griffin.
My question is, when you did that A, how do you, like, I get your processing,
Yeah, absolutely. You could do that. So you could take out that 3 first and do x squared minus 4x plus 3. Much easier to work with, isn't it? What would you have to do on this one? You'd rewrite here, I can do this one real quick. I would rewrite this as the integral of 3x to the -1/2 plus 4x to the, that's it, right? Isn't 3/2 minus 1/2 1? D of x. And then, Eli, I'd take the integral of 3x to the -1/2. A lot easier to do it that way, isn't it? And do each of them separately if you want.
Wait, so was that the answer?
No, I never took the antiderivative. You can do that on your own.
Okay, so after
Yeah,
you get that.
after I do that, then you need to take the antiderivative of each part.
Okay.
Let's do a trapezoidal rule. Use trapezoidal rule to approximate from I know that's a 1 to 2 of 1 over x plus 1 quantity squared d of x when n equals 4. So b minus a 2 minus 1 divided by 4, so it's 2 minus 1, 1/4, but 1/2, because trapezoidal rule is 1/2 the height. So it's 1/2 b minus a over n. So 1/4 times 1/2 is 1/8 times. Now we're going from 1 to 2, and we're going to have n equals 4. So this is going to be 1, we already said it was 1/4 increments, right? So 1 1/4, which is 5/4, 1 1/2, which is 3/2, 1 3/4, which is 7/4, and then 2. So 1/8 times f of 1 plus twice f of 1 5, what is that, 5/4? Plus twice f of 3/2 plus twice f of 7/4 plus just 1 of f of 2. Now I haven't crunched these because I'm letting you do that. I have it written there. I'm gonna grab my calculator too. Let's see if we all can come to the same answer.